SwayamPrabha. Digital India. Educated India.
Welcome back. Today we will be talking about job strain index. Okay, JSI. It's a very useful tool when we are talking about any activity which is repetitive in nature and it is involved with your upper extremity. So job strain index, it's again a physical method. It helps the researchers to understand what is the impact of awkward posture, then repetition, forceful exertion and varieties of things which is associated with such activities and how we can quantify them. So there are we will take this tool as the same way as we did for the earlier tools. First we will introduce, we will go for the procedure, then we will take it for an example and then definitely some advantages and disadvantages we will talk about. Fine. So let us begin. So this particular tool is being introduced by Professor Murray and Garg in 1995. So you can understand it's not very old tool, it's quite new when actually these physical methods or physical activities were very prominent in industries, right? So right now if you take the incidences for after the industrial revolution, most of the work is sedentary in nature and lot of cognitive aspects are need to be considered, but at the initial stage of our ergonomics field evolution, that time lot of these researchers work for different kind of physical methods to identify or assess the load, physical load on the human body while working. Definitely in these many cases these tools are context specific. Here like job strain index is also very much context specific. So this particular strain index was proposed by Professor Murray and Garg as a means to assess the job for risk of work related musculoskeletal disorder. So only it evaluates, so before we take this tool as a measurement procedure for in our research or in our research activities, we should understand what it actually does. It only actually evaluate the hand, wrist and elbow. So we talk about it distal upper extremity. So from elbow to this finger, okay. So this only it is going to evaluate. So if any job which is associated or which is connected to hand, wrist and elbow, which involves the hand, wrist and elbow like distal upper extremities, you can use this tool to assess or evaluate the strain index for that particular job. So it assesses the task based on the posture, frequency and force. So how does this particular tool actually work? It work based on the posture adapted by the person, the frequency and the force. It never considers the vibration, contact stress or some other criteria or other stressors for the musculoskeletal disorders. So only it considered the posture, frequency and force, not the vibration, not the contact stress. So it's a indexed based and it's a relative risk. Okay, it's an index based relative risk. So let us go little more detail. It can assess the right and left side independently, as well as the worst courses. So, you are doing the analysis, suppose both the hands are similarly working, still if you want you can have right analysis separately, left analysis separately, or you can choose that which part you would like to analyze. Many cases, as I mentioned for the Rula and Reba and all those cases, that many cases what we do, we take the dominant hand, okay, we take the dominant hand for our analysis. That also you can do, or you can do the both hands separately. Most like at the initial stage when this particular tool came into existence, they identified that meat packaging industry, small part assembly, keyboarding, or any such activity which is similar to those cases this particular tool is very much useful. As I mentioned that it is only useful when your distal upper extremity is involved in that particular job. So, for those job which requires rigorous involvement of distal upper extremity, for those cases you can use JSI or job strain index. Before we go into more detail, let us understand what are the factors involved in this particular index calculation and what is the formula of it. So, first there are total 6 factors, okay, 6 index element. First is intensity of exertion, second duration of exertion, that is percentage of cycle, efforts per minute, hand wrist posture. So, it is not about whole body. When we are talking about distal upper extremity, mainly we will be talking about the hand wrist posture, speed of work and duration of task per day. While calculating the job strain index, we will come to know about one important terminology, that is the multiplier. What is that? There are some constant factors which we will come to know when we will go in the more detail. So, each factor or each element, that intensity of exertion, that will get converted through a pre-computed table into a multiplier through a rating, from a rating to a multiplier, okay. And once we multiply all these 6 multipliers, we will get the score, that is the index, okay, job strain index, or we call it JSI score. Then we will compare that particular JSI score with the level, as it is an index, so there will be some level. So, that we will compare and we will say the job is hazardous or risky, or is it going to have any impact in future on the musculoskeletal system or not. So, assign a value for each of these elements, that is the mandatory portion. We will do how we can assign them, multiply each element, then we will get the index and compare the calculated value with the decision threshold point. So, if we get a value less than 3, we will say it is safe, the work is safe. If it is 3 to 5, then it is uncertain, maybe there is some unsafe activities are present. So, you need to go for some kind of intervention or more investigation. 5 to 7, it's somewhat risks available, it is confirming yes there are some risks, and more than 7 it is confirming yes it is very much hazardous. So, you need to look into the job, look into the construction, look into the procedure, and you need to do some kind of intervention. Okay. So, this is the scale that you will be using. So, at the end, whenever you are getting the JSI score by multiplying all these multipliers, okay. So, this particular JSI score you will be comparing with this value. If it is less than 3, then it is safe, 3 to 5 uncertain, 5 to 7 somewhat risk, and more than 7 it is hazardous. Now let us begin. How can we understand and how can we score these 6 elements? First we will go for intensity of exertion. So intensity of exertion, we can do the rating in 4 varieties, in 4 different way. Okay, in 4 different way we can do the rating for intensity of exertion. So this is the rating. You have 5 points, 1, 2, 3, 4, 5. These are the 5-point scale. So 5 ratings you can do. Now how do we do? Either you can have a 5-point rating scale in where 1 means light. The intensity of exertion that is perceived by the person who is working over there is feeling light. 2 means somewhat hard, 3 hard, 4 very hard, and 5 depicts near maximal. So 1, 2, 3, 4, 5, right? So this way you can have a 5-point Likert scale and you can use that. If this particular method is not useful for your scale, then you can go for some other way to rate the intensity of exertion. The next way is you need to calculate the percentage of maximum strength used by your distal upper extremity. How do you do that? So you can calculate your maximum voluntary contraction while in the posture of the particular work is being done, and then you can have data from maybe different method you can use, and you can calculate the what is the percentage of maximum strength is being used in while doing this particular job. So suppose you are tightening some screw, okay, in a particular job, and you are trying to identify the intensity of exertion of that particular job. So what we will do in that particular activity, in that particular posture, in that particular manner, what is the maximum possible voluntary strength can be generated of those group of muscle. First you measure that and you measure the working strength, okay. Then you calculate what is the percentage is being used of maximum voluntary contraction while doing that particular job. So once you have the data, then you say if it is less than 10%, then it is 1, 10 to 29%, then it is 2, 30 to 49%, it is 3, 50 to 79%, 4, more than 79%, it is 5. So this is another way. If it is also not possible for you to do, then you can use Borg's CR10 scale to get an understanding what is the intensity of exertion in that particular job. So you know how the CR10 scale looks like. I explained it earlier. In that, if any value which is less than 2, it is 1. If between 2 to 4, it is 2, 4 to 6, it is 3, then 7, 8, it is 4, and more than 8, that is 10 and above near to those location, it is 5. Okay. So that way you can have intensity of exertion using your Borg's CR10 scale. The next way of doing is how the person is perceiving that particular intensity of exertion. So this is more of the answer from the subject, okay. So how the person is perceiving it. So if he or she is perceiving barely noticeable, he cannot perceive. So, it is very light. Okay. So, for that cases it is 1 noticeable or definite effort, then 2 obvious effort or unchanged facial expression. So, it is connected to, so if you need lot of effort to do, of course your faces will, facial muscles will work, right. So, if you are doing some very tough job with your these muscles, automatically your facial muscles will react. So, if unchanged facial expression, but you can see the effort is there, then it is 3 substantial effort and changes the facial expression of, then definitely it is more than that, then it is 4, and use shoulder or trunk to generate force. So, it is not only happening with your distal upper extremity, you are taking effort from your shoulder and trunk muscle. So, lot of activities are happening. So, you can see the posture is changing. So, those cases you can give a rating of 5. So, this is how we get the rating of intensity of exertion, correct. This is first element of JSI. This is first element of JSI. Moving to next element, that is the duration of exertion. How do we calculate it? The calculation is percentage of duration of exertion is equal to effort duration per cycle time multiplied by 100. So, in a whole thing, that particular effort is taking how long divided by the whole cycle time, okay, multiplied by 100. So, if a particular job in a particular movement or particular task, that particular effort is taking 3 seconds time and the whole cycle time is 10, then it is 3 divided by 10 multiplied by 100. Fine. So, this way you can do the calculation of percentage duration of exertion. So, here you can see the value is 30. 30 means we are here, correct. So, here also you can have a rating. If it is less than 10 percentage, then it is 1, 10 to 29, 2, 30 to 49, 3, 50 to 79, 4, and more than equal to or more than 80, then it is 5. So, we can have the rating of duration of exertion. Good. Let us move to the third element. Third element is efforts per minute. The earlier element was for that particular effort, how long you are taking in the whole cycle. Now, we are going to calculate in a minute how many time we are producing that or we are doing that particular effort. Okay. So, efforts per minute is equal to number of exertion per cycle divided by cycle time. Everything you need to calculate per minute. So, if the number of efforts per minute is less than 4, then rating is 1, 4 to 8 rating is 2, 9 to 14 rating is 3, 15 to 19 rating is 4, more than 20 rating is 5. Very clear? So, till now we completed 3 elements. Now, let us go to the next element. Next element is hand wrist posture. So, here it is, we are talking about a distal upper extremity, right. So, whatever we are doing with our wrist, hand wrist and using elbow. So, now we will be talking about hand wrist posture. There are again 5 ways that we can give the rating. You can use any one of them. You need not to go for all. You can take any one of them. Okay. First one is rating criteria, like in a 5-point scale. You can ask the person or you can rate yourself that If it is very good, 1, good, 2, fair, 3, bad, 4, very bad, 5, right? Or you can have angular measurement of deviation. What? This is extension, flexion and ulnar deviation. This also you can measure. So, suppose you are working in this particular posture. So, you can measure the degree, right? At what degree it is being in extension, it is in flexion, it is deviated, right? So, any one you can choose. You can see the degrees accordingly, it is mentioned what is the rating. So, for wrist extension, wrist flexion and ulnar deviation. Now, it may happen along with extension and flexion, some ulnar deviation is present. In that case, you may ask a question that which value you should take. Here, as it is a risk assessment tool, you should always go for the higher value. For example, suppose in a particular wrist posture, your wrist is flexed at 16 to 15 degree along with 16 to 20 degree ulnar deviation. Okay. So, if you take only flexion, the rating is 2. If you take only ulnar deviation, it is 3. Okay. As both things are present, you should go for rating of 3, not 2. Why? If you take the rating of 3, then you are going to cover maximum possible risk present in that particular activity. So, that is why you always need to go for the higher value. Now, this way you can calculate. So, here maybe you can do photographic method or you can use goniometer or any other method where you can measure the wrist posture. Also, here you can use your perceived posture, how you are perceiving that posture. So, if you feel that it is perfectly neutral, then 1 near neutral, 2 non-neutral, 3 marked deviation, 4 and near extreme, the deviation is near extreme, then it is 5. So, these are the way how do you define your hand wrist posture for job strain index. Okay. So, you almost covered 4 elements. Now, let us move to the next element, that is the speed of work. Again, here we can do the rating in 2 varieties, two ways. Okay. 5-point scale, very slow 1, slow 2, fair 3, fast 4, very fast 5. Fine. So, that you can do, or you can give a perceived rating, extremely relaxed pace. So, there is no hurry. Now, slowly the person is working. There is no pace. It's very relaxed. Taking one's own time. It's not that very relaxed, but yes, he or she is completing the task on its own time. But it is doing. It's not that it's not happening. It's very slow. It's doing on time. Okay. Normal speed of motion, rushed but able to keep it up. Okay, doing very hurry-burry, but it's not that something is missing up. It's doing, but you can see the speed, and rushed and barely or unable to keep up the speed. So, then it is 5. So, this is perceived. Okay. Now, this always comes with experience. It's not that at the very beginning, once you start collecting data, you will be able to understand the discrimination between 1 and 2, then 3, 4 and 5. This is very difficult to understand. So, based on your experience, based on your skill, you will develop it. So, always here we suggest to have 2, 3, 4 number of observer so that based observation can pick it up. So if one observation is very different from other 2 and 3, you can again redo the task. Okay. So this is always like for the learner, like for the person who is doing these things very first time, or maybe at the very beginning of their research life, they take their peers' help to collect these data, not only for speed of work, for all other elements. Okay. Or once you have the video recording of the job, you do it at laboratory for many times and you cross check, okay, that what you did earlier and what you do now is matching or not. So biasness, elimination of biasness, so those things you will practice and then it will go off and you will have more accurate data. Okay. So this is speed of work. Moving to next, that is the duration of task per day. This is very specific, that how long they are doing the job, doing that particular task. So if it is less than 1, you can get this from their work schedule, right? So it's less than 1, then 1, 1 to 2, 2, 2 to 4, 3, 4 to 8, 4, and more than 8 hours. Everything is in hours. Okay. So more than 8 hours, then it is 5. Now you understood all the 6 elements of job strain index, right? Now what we did till now, we just did the rating of each element. Now here we have to convert them into multiplier. So there is some pre-computed table. So this is how it looks like if you combine all the things. Now this is how the multipliers look like. This is the table where all the elements are placed along with the rating. Now this is how the multipliers look like based on the rating. Okay. So these all are multipliers of intensity of exertion. These are for duration of exertion and so on. Now, right? Now just take one small example. Suppose I am picking these values. Maybe from my experiment these values are coming. So intensity of exertion is 1, duration of exertion is 1, efforts per minute is 0.5, maybe hand rate posture is like 1.5, maybe speed of work is 1.5, and duration per day is 0.7. So what is your JSI? JSI is 1 multiplied by 1 multiplied by 0.5, 1.5, 1.5 multiplied by 0.75. So calculate the value. This will be your JSI score. Fine? Clear? Now let's take an specific example and then we will show how do we interpret the result. So I am explaining a scenario, an operator. First let me read it out, then we will take it further. So an operator in a manufacturing industry's batch production system must assemble a component. So job is, in a batch production system they have to assemble some component. One of the tasks is to align 2 components which are weighing around 5 kg in total, which takes around 10 minutes when performed at a comfortable slow pace. So here you are getting an understanding how things are being described. The operator performs the task at a comfortable pace with good hand and wrist posture. So this is the definition of the scenario or description of the scenario. Now from this scenario, what we try to do, this is just an example, okay. You can have your own example and you can calculate. So what we did, we rated everything, okay. So this is 2, this is 1, this is 3, this is 2, this is 2 and this again 3. So, accordingly we got these multipliers from this pre-computed table. From this pre-computed table we got all these multipliers, and then once we multiply we got this value as 1.68. 1.68 is your JSI score. Now, what do we do with this? Yes, let us move forward. Again, this value. So, 1.68, of course, it is less than 3. So, the particular task or particular job which is we are actually analyzing is safe. If by chance that particular JSI score, suppose for a particular activity is 6.2 for a case, then it is here. So, that means there is some risk. There is some risk in that particular job. So, what we supposed to do? We supposed to inquire back that why this particular score became high. And how do we do that? We look at the individual value. All the 6 values are there, right? So, we look at each individual value and check which value is causing the higher value of the total score, that JSI score. And if we see, yes, there are some score which is actually causing the higher value of the JSI, then we through intervention we try to modify it, and once we modify, again we cross check that is it reduced or not. If it is reduced, then yes, your intervention is successful. If it is not reduced, is same, then your intervention is not successful. So, you need to rework on it. So, this is how we use job strain index, and using job strain index, this is how we go for the intervention. Now, let us talk about advantage and disadvantage. So, advantage, if we talk about this particular tool, is like you get 6 elements in a particular job, and you see how these 6 elements are connected to develop or how these elements are useful or influencing the development of musculoskeletal disorder. So, very easily you can have some idea that where your intervention can start. This is one. Second is, it's very easy method. Maybe after 1 or 2 training, any person can adopt this particular method and they can do the data collection as well as analysis. It does not take lot of instrument, maybe a simple video recorder and pen and paper you can use, you can collect data and you can have the analysis. So, very useful. However, there are some disadvantages, there are some limitations. So, what are those limitations? Limitations are, it talks about only those cases where distal upper extremity is involved. If any job which requires whole body involvement, this particular tool will not be able to assess the risk factors connected to musculoskeletal disorder. So, only for distal upper extremity, for those cases only this tool is useful. So, this is the limitation of this particular tool. This is quite a reliable tool. So, I suggest if anyone is working in a with any some occupation where distal upper extremity is involved, to do some kind of assembly job, repetitive job, then you can use this tool, you can implement this tool and you can assess the risk factors to, which is related to musculoskeletal disorder. That's all for today. So, if you have some questions, you can put it in discussion box and you can practice it, and while doing or while practicing, if you have some difficulties, that also you can inquire back. Thank you.